Okay, so we're going to take a look at the Knight Rider assignment in Tinkercad and work through some different versions of how to deal with making the project work. I'll just mention that the starting point for this was to work on some of to work on the exercises that we did originally, at least with my class, which was the Spark Fun Inventor's Guide exercises. We worked on 4 of those. And there are also videos that are covering basic programming ideas in Arduino and C on this channel. So we looked at creating variables, using conditional statements, and looping. And all of those things should have you fairly well prepared to proceed with this assignment. If you haven't looked at some of those, you should go back and do so. The assignment is to create a kind of animated LED effect that comes from this TV show, which if you Google it, you'll probably end up here quickly on the NBC site. It was a TV show that was broadcast back in the 80s, and it featured this car. And you can just see a bit of a red glow here. This car was, this futuristic uh, car that had this incredible AI kit, it was called, and it could, talk. It could do all sorts of, planning and thinking and helping out uh, helping out to solve crimes or do whatever. And it had this animated, you know, LED at the front. So just watch this LED for a moment. I'll just kind of hit play there. It's kind of hard to see there. I should really just slow it down, but it's going back and forth. And so you can, what we're trying to do is model that, and it looks like they're almost all on, but I think this is the bright side of it, and these are actually faded out, and it's kind of traveling in this direction, and these faded out parts will kind of fade even more, and then it will kind of go in the next direction. So you can, that's what we're trying to create. So let's just see if we can just see a bit more of that and slower. It's really kind of choppy. So that's the effect we want to create, and there it is. There's a good shot of it. Now we'll start out just by creating something where the LED lights up and moves to the next one, and we'll leave the fading for the next video, and we'll leave the better techniques of dealing with some of this stuff for the next video as well. So here is my setup. You need first some kind of setup that's got enough LEDs. I would say maybe 6 LEDs would be a good number. And I have the potentiometer and the push button here for later, but we won't be using those just yet. We'll try to get the potentiometer working. And I've done a little bit of color coding here, so my black wires are ground wires and my red wires are connected to plus 5 volts on the Arduino. The circuit for the LED, I'll just come into this one here. So this is hooked up to pin 3, and pin 3 is going to provide plus 5 volts for us. So when we turn it on, that on and write a digital write high to pin 3, we'll get 5 volts from this wire, which will then go through this 220 ohm resistor. This is a current limiting resistor so that we don't drive too much current through the LED. In real life we could burn them out, and in the Arduino, in Tinkercad, you get a little burnout kind of overdrive symbol. So plus 5 volts through the resistor into the positive lead, out through the negative lead, and then into the wire that goes off to ground on the Arduino to complete the circuit. And I've done that with each of those LEDs, a similar circuit. I have used, you'll notice here, I haven't used a sequential, like I haven't used a series of pins here. I haven't gone 3 4 5 in order. I've skipped a number, and the reason for that is that I wanted to make use of PWM. So if you look at pin 3 here, it has that tilde symbol, that wavy line that's on the key to the left of your 1 key on your keyboard. And if you remember from the Spark Fun exercises, this is a PWM, pulse width modulated enabled pin. So this pin is able to simulate an output between 0 and 5 volts by quickly switching on and off, and that will allow us to fade the LED in some future steps. So rather than having to rewire my LEDs later when I realized I wanted to use PWM, I've hooked them all up, and this is going to help us down the road. For now, we're just going to remember what those pin numbers are: 3, 5, 6, 9, 10, 11, and I think I've already got them in my code. I'm actually going to get rid of this. I'm just going to pretend that I'm going to pin mode everything. I'll talk about this in the next video, but what we really need to do here is pin mode all our pins to be outputs, and without the use of that array, I would just copy and paste this and manipulate the numbers here. So 9. Alright, so there's our 6 LEDs. 3, 5, 6, 9, 10, 11, all configured to be output pins. I've also included this serial output because this is always good for tracing, and I have a commented out print statement which I might use if I need to trace some values. And so I'll just think about trying to create this animation for a moment. Oops. Using the most basic kind of approach, and that would be to simply flash the LED as we've done in the past by digital writing to it, and we want to turn it on. We want to delay for a moment, so we'll just set this delay amount. Let's just set it using a variable, a global variable. We'll just call it pause time, delay time. Oops, delay time. And I'll set it to a short amount, 200 milliseconds, say. So we will switch on pin 3, and then we'll delay so that we can actually see it turned on, and then we will switch it off and delay again so that we can see it while it's off. Alright, so and that should just continue to loop the LED on pin 3. Maybe too quickly. I'll just set it right to 1 second for each. And sometimes your version of Tinkercad won't be running at kind of real time. If you look at simulator time here and look at the speed at which the time is counting up, this looks like about a second. So it looks like it's running fairly smoothly right now on my machine, and we see a flashing LED at about once per second. So the process from here would be just to continue with the LEDs and do them in order. So this was pin 5 on this one, and we would go to the next one, and we'll just build it up like that. So this one turns on, then this one, and you would proceed to go through the full 6 LEDs and then come back in the other direction. And this, I think this really helps understand how to get this up and running, even if it's the way it's being done is a little bit basic. The other thing you could think about at this point is that if you're going to move to, if we called this LED 1, for instance, and we called this LED 2, it might be that when LED 2 is on and we're going right, that we want LED 1 to be on a kind of a half value amount. So let's just talk about that for a moment. We can, as we covered before, you can simulate this using analog write. So, and don't forget your Arduino reference. It's always good to have that open and ready to consult. This, if you have forgotten or need to refresh your memory, this analog write allows you to write a value that will simulate brightness or voltage using this pulse width modulated wave, square wave. And we can write values that are between 0 and 255. And we have to say the pin number first and then the value to write it. So for instance, here's a version of that. I'll just grab that and place it into the example code. So what I'm interested in right now is creating a half value for pin number 3. So this is half on, and of course this is still off. So what you'll see on the second part of this is that this will be fully on and this one will be half on. Oh, I didn't actually mean to do it that way, so I want to put this in here. And I mean, it's not really working the way it should be, where it's turning it off as well. So let's just try to get this. Okay, so this is kind of our step 1 here, where LED 1 is on fully. And this will be step 2, where LED 1 is on the half amount and LED 2 is fully on, and then we'll be looking at step 3 next. So this will not be step 3 in the end. We'll change that, but let's just see if we've got the first one working as fully on and then half on. And you can see that half on is actually maybe not as faded out as you might like. Let's just kind of half it again roughly and see what that looks like. So there, I think that looks a little better. It's a little hard to, the brightness on Tinkercad is a little hard to get right. So that might be even it. It's right down to 30 on that value. And then step 3 might be that, this, I think we probably should switch to all analog writes at this point. This goes down to 35. This can pretty much go down to 0. And of course we should be writing the next one, which was the 6 pin to fully on. So there. So I think we're seeing a nicer version of it using the analog write and delay. And you can see you want to spend some time kind of crafting this and getting it working and having a feel for what's going on with the analog writes. And we will explore doing this in a more programmatic and sophisticated way on the next video.